Hello, algebra students. Mr. Lawrence here. And I don't know how long that was, but it was long enough because I'm out of breath. Anyway, this is your first of two review videos. This will be part one. Trying to get you ready for the test. It's going to be later this week. All right. First off, let's get right down to this. We have a graph in front of us. Now, the graph doesn't have a title, but I think you can figure out what this graph is about anyway. On the vertical axis, we've got the distance in miles, and on the horizontal axis, we have the time in hours. I think you can tell that this is a distance versus time. Considering the large number of miles along here, it's probably safe to assume the person is driving. I guess it could be boating or maybe a small aircraft, but anyway, so you should be able to look at stuff and be able to tell what's going on now. You've got enough experience. Looks to me that like this person didn't start their trip on time, that they started like sometime into the trip. Like maybe they got delayed, they packed up the van, got ready to go, and then the kids had to go potty or something like that. But let's see what we're counting by here. I mean, I see 1 hour here, but I see 1, 2, 3, 4 blocks to get there. So I'm guessing each block is 15 minutes. Yeah, each block is 15 minutes, but since we're doing time in hours, I guess I should put 1/4 there, huh? That would make more sense. All right, well, let's see if we can figure out some different pieces of this graph. Let's see if we can figure out the speed of this person for this little line segment here. Okay, well, let's see how much time took place. The time looks like it's 15-30 minutes or half an hour. Okay, and then the distance that they traveled, is, let's see, 45 miles on the nose, isn't it? All right, if I use my equation, d equals RT, I'll put 45 into the distance, and my rate is unknown, and my time is 1/4 of an hour. Oh, no, it wasn't. It was a half an hour. Excuse me. I looked at the graph a second. Now, I don't know if you realize this, but instead of dividing by a half, to get rid of this fraction, I could go ahead and multiply by 2. I could multiply by 2 over 1. And over here, I'll just multiply by a plane over 2. And watch, Wonder Woman will do her thing. Sorry, I didn't sing the song for you there. And 45 times 2 is 90. And so the rate there would be 90 miles per hour. Whoa, this person is driving fast. Maybe they're on the Autobahn. I don't know. All right. Let's see if we can figure out the speed from this point. We'll call that point A. We'll call this B, and we'll go B to C. All right, and you notice I just can't use one point. I have to figure out how much change has taken place. Oops, sorry about that. Let me go ahead and close my email here really quick so nothing pops up that shouldn't. All right, so let me move this 90 miles an hour over here. That's for that first stretch of graph. So let me see what's going on with this second part here. Okay, it looks like the time, in this case, the time from point B to point C is 1, 2. Oh, it's a half an hour again. Okay, that'll make it easy. And then the distance looks like it might be 90 miles. So the distance is 90. And so then I can do 90 equals R times a half. I'll tell you what I'll do on this one to show you I can do it the same way. I'll actually divide by a half. Okay, and if you remember, 10 divided by half was 20. Remember that from like the first week of school? So 90 divided by half must be 180. Oh my goodness, this person is flying. Probably literally. If they're going 180 miles per hour, it's probably not a car. Could be a car, or maybe the person's changing modes of transportation. I don't know. Okay, but they went 180 miles per hour here. Now, can you tell me the speed that they're traveling from C to D? That should be a simple one. They're traveling 0 miles per hour because they're not going any distance. Okay, and notice that's a horizontal line segment. We came up with 0. Later on, when we do something called slope, that's going to be really important. If you wanted to set up the equation, it goes 0 for the distance, the rate's unknown, and the time looks like it's half an hour again. And so if I divide by a half on both sides of the equation, oops, I'm going to get 0 divided by a half. Some of you have trouble with that. But look, we already told me the answer was 0. So you know 0 divided by a half has to be 0. You know 0 divided by 7 has to be 0. 0 divided by 100 equals 0. Okay? Start making connections. Start thinking about the answers you already know, using those easy answers to help you with the things you're not so sure about. All right, finally, we're going to do point D to point E over here, and I guess I should get a different color. Maybe I'll go orange. All right, and this time it looks like we've got 1, 2, 3, 4, 5, 6, 7, 8. There's 2 hours. 1, 2, 3, 4. There's 3 hours. 3 hours and 15 minutes. So 3 1/4 hours is our time. Now you might want to go 3 25/100ths. You might. I think I'm probably gonna stay mixed number here, but and turn it into an improper fraction. Now let's see what my distance was. It was from here. Each one is 1, 2, 3, 4. Let's see, 1, 2, 3 is 45. So each one must be 15. So this distance here must be 60 miles. So my distance is 60. My rate is unknown. And I've got this 3 1/4, and I'm going to turn this into 13/4. And I think this is going to be an ugly answer, but I'm not afraid of it. 13/4. Okay? And so I'm going to do a little Wonder Woman trick here. I'm going to multiply by 4/13 on both sides. 4/13 on both sides. I'll put the 60 over 1. Wonder Woman will cancel the 4s, cancel the 13s. The right-hand side will have an R. Now, I'd love to do a Wonder Woman trick over here, but I don't see anything that's going to simplify. I don't see any common factors. So I'm going to double 60, get 120, double that, and get 240. And 240 is going to be divided by 13. Normally, I would go ahead and figure this out on my own, but, this is getting ready for a test, so we're going to go ahead and use a calculator. And I'm dividing 240 by 13. And I got a strange answer of 18.46 about. Now, I don't really like that, but I'm going to go ahead and leave that there for now. It's about 18.5 miles per hour roughly, and that's the speed. So whatever happened slowed them way, way down. I don't know, maybe like a hurricane force headwind if they're in a plane. I don't know. If I was only traveling 18 miles an hour in a plane, I think you'd probably fall out of the sky. But that's okay. All right, so here's 3 tables. We have to try to figure out what type of pattern it is, right? Linear, quadratic, exponential. Oh, excuse me. So let's go and find our first differences. Looks like it's +3, and that's +5. That's +7. Some of you know already it's quadratic, don't you? +9. But again, go to the second difference, showing it the same. And it is quadratic. And remember, your reason is because the second difference is constant. The second difference is constant. All right, let's go to this one over here. We're going -2 to +4. That'll be 6. This looks like it'll be 18. Oh, I've got a suspicion of what it is already. Let's see, 22, that's going to be 54. Yep, it's times 3 every time, isn't it? It's times 3 every time. It sure is. If it's multiplying by 3 every time, then it's exponential. Multiplying by 4, multiplying by 5, exponential. There we go. Exponential, and the reason is the differences are being multiplied by a constant factor, namely 3 in this case. All right, this last one here looks like it's going -2, -2, -2, -2. This must be a linear pattern, and the reason is it's going down at a constant rate. As each x goes up by 1, y is going down by 2. All right, let's see here. We have to perform the indicated operations, simplify, and then classify the answer by degree and number of terms. All right, looks like I need to do a little distribution here, so I'm going to multiply, and so I'm going to get 15x squared minus 20x. And then I got to distribute this negative here, and here, and here. And when I do that, I'm going to get a negative 20x. I'm going to get a negative 15x squared, and then I'm going to get a positive 7. And so, combining like terms, these are going to cancel. This will give me a negative 40x plus 7. And its degree is 1, right? Remember that invisible 1 right there? Oop, there it is. So that makes it linear. Well, you probably can't read that very well. That makes it linear. And there are 2 terms, which makes it a binomial, a linear binomial. All right, here on this one, remember I strongly suggested to many of you to write it out twice. So I'm going to do this problem as 2x, oops, let me get to the skinny pen, times 3, the quantity of 3x plus 2, and then minus 4 times the quantity of 3x plus 2. It is very important to take that sign with that 4. Very important. So I'm going to distribute like that and get 6x squared. Yeah, I paused there to see if some of you would accept 6x. Remember, x times x is x squared. And then I'm going to distribute here, and I'm going to get a negative 12x minus 8. All right, and I'm going to highlight my like terms. Oop, I don't have any other x squareds. I've got 4x and a minus 12x, and that negative 8 I'm not going to highlight because he doesn't have anybody to go with either. So I'm going to have 6x squared minus 8x minus 8. Now this highest power is 2, so therefore this is a quadratic. And there's 1, 2, 3 terms. And so therefore it's a trinomial, a quadratic trinomial. All right, going on to this one. These seem to give a lot of you trouble. Just have to ask yourself what this means. It means that there are 3 of these. 3 of the x minus 1s, right? Yeah, that should be familiar. Okay, now, I know a lot of you get confused, you don't know what to do. Well, just pretend that for right now, oh, there we go, it worked. Pretend for right now, the shade just isn't cooperating. Sorry about that. I don't know why there's such a lag there. Pretend it's that problem, okay? And so I'm going to do that problem. That's not the entire problem, of course, but I'm going to write 3x times the quantity of 3x minus 1, and then the minus 1 times the quantity of 3x minus 1. I'm going to distribute here and here, and I'm going to get a 9x squared minus 3x, and then minus 3x, and plus a 1 when I distribute the negative 1, right? I'm going to keep that in a quantity. I'm actually going to simplify it. 9x squared minus 6x plus 1. And then I'm going to get rid of the shade, and I'm going to bring down this 3x minus 1. And so now I'm going to distribute him. Uh-oh, I'm running into my next problem here. That's the great thing about the smartboard is I can move the next problem down to give myself some room. Oh no, I lost my period. Period, where are you? Come here, period. Ah! The period does not want to move. There it goes. Okay, so now I'm going to write this out the long way. So I'm going to take a 9x squared, and I'm going to multiply by 3x minus 1. And then I'm going to take a negative 6x and multiply it by 3x minus 1. And then I'm going to take a positive 1 times 3x minus 1. Going to distribute here and here and get 9x. Nope, not going to get 9x. I'm going to get 27x cubed minus 9x squared. And then I'm going to distribute here and here, and I'm going to get negative 18x squared and a positive 6x. And there's really no distribution. You can say you're going to distribute, but multiplying by a positive 1 doesn't change anything. So I just am going to write that down. Now, looking for like terms, kind of cool in this problem because they all ended up near each other. I got this guy and this guy together. And I've got this one here with this one here. And then I'll tell you what, I'll just slap a green on that guy. And I'll blue on this one so we don't accidentally put those together. All right, so I'm going to simplify, and I'm going to have 27x cubed minus 27x squared plus 9x minus 1. Now the highest power here is 3, so therefore this is a cubic, right? And there's 4 terms, so we say it's a polynomial. And there you go. All right. So find the area of the rectangle with dimensions of 5x plus 1 by 2x plus 4. Well, I'm going to draw a rectangle. Yeah, I'm going to draw myself a little rectangle here. Actually, just draw the 2 sides. Put a little mark on each side, just like that. And we're going to have a 5x and a 1. And over here, we're going to have a 2x and a 4. And then I'm going to finish off my rectangle. And I'm going to go like that. And skip-a-da down there and bring him down. And then bring him across. And I'm going to find the area of the 4 little rectangles inside. And then add them all together. And I'll know the area of the big rectangle. So 2x times 5x is 10x squared. 2x times 1 is 2x. Feel a sneeze coming on. Excuse me. All right, 4 times 5x is going to be 20x. And 4 times 1 is going to be 4. So when I put them all together, I have a 10x squared plus 22x plus 4, and that'll be centimeters squared. Right, and that's a, a quadratic trinomial. I think that's it for this video. We've gone long enough. Look for part 2 real soon. Mr. Lawrence signing off. Have a good night, everybody.